It is a code violation to plug a non-grounding type plug on a light fixture into a grounding type receptacle. National Electrical Code Section 406.4 D4 states grounding type attachment plug shall be used on all receptacles installed on general-purpose branch circuits. National Electrical Code Section 406.9 B states receptacles shall be grounded by means of the grounding conductor in the outlet box. Grounding provides a path for fault currents to safely return to the electrical panel, protecting equipment and personnel from electrical shock. When a non-grounding plug is used in a grounding receptacle, this path is missing, creating a potential safety hazard. To comply with the National Electrical Code, the owner should either replace the non-grounding plugs on the light fixtures with grounding-type plugs or modify the light fixtures to connect directly to the branch circuit wiring using a junction box or hardwiring. Let's delve deeper into the specific National Electrical Code requirements and the underlying principles of electrical safety that make this a code violation. The National Electrical Code, or NEC, is a comprehensive set of standards and guidelines designed to ensure the safe installation and maintenance of electrical systems. It's not just a suggestion, it's the law in many jurisdictions, and compliance is essential to prevent electrical hazards. Section 406.4 D4 of the NEC specifically addresses the types of attachment plugs that must be used with receptacles on general-purpose branch circuits. A general-purpose branch circuit is simply a circuit that supplies power to a variety of outlets for lighting and appliances. The code mandates that these receptacles must use grounding-type attachment plugs. This means that the plug must have a grounding pin which connects to a corresponding grounding slot in the receptacle. This grounding pin provides a path for fault current to flow back to the electrical panel in the event of a ground fault. Section 406.9 B reinforces this requirement by stating that receptacles must be grounded using the grounding conductor in the outlet box. The grounding conductor is a wire, typically green or bare copper, that connects the receptacle's grounding terminal to the electrical panel's grounding busbar. This conductor provides a low impedance path for fault current, ensuring that the circuit breaker trips quickly in the event of a ground fault. The reason why these grounding requirements are so important is because they protect people from electrical shock and equipment from damage. In a properly grounded electrical system, if a fault occurs, such as a live wire coming into contact with a metal enclosure, the fault current will flow through the grounding conductor back to the electrical panel. This high current will cause the circuit breaker to trip, quickly shutting off the power to the circuit and preventing a dangerous buildup of voltage in the metal enclosure. If the electrical system is not properly grounded, or if a non-grounding plug is used in a grounding receptacle, the fault current may not have a low impedance path back to the electrical panel. In this case, the fault current may flow through other paths, such as through a person who comes into contact with the energized metal enclosure. This can result in a serious or even fatal electric shock. In the scenario described, the owner's use of non-grounding plugs on the light fixtures creates a significant safety hazard. The grounding receptacles are designed to provide a path for fault current, but the non-grounding plugs prevent this path from being established. This means that if a fault occurs in one of the light fixtures, the metal enclosure of the fixture could become energized, posing a shock hazard to anyone who touches it. The inspector is correct in requiring the owner to modify the light fixtures to comply with the National Electrical Code. There are two acceptable ways to do this. Firstly, the owner could replace the non-grounding plugs on the light fixtures with grounding-type plugs. This is a preferred option, as it ensures that the light fixtures are properly grounded and that the grounding system is functioning as intended. To do this, the owner would need to purchase grounding-type plugs that are compatible with the live fixtures and have a qualified electrician install them. The electrician would need to ensure that the grounding conductor in the light fixture is properly connected to the grounding pin on a new plug. Secondly, the owner could modify the light fixtures to connect directly to the branch circuit wiring using a junction box or hardwiring. This involves removing the plugs and receptacles altogether and connecting the light fixtures directly to the circuit wiring using wire connectors and a junction box. This option is less desirable than replacing the plugs, as it makes it more difficult to move or replace the light fixtures in the future. However, it is an acceptable option if replacing the plugs is not feasible. Again, this work should be performed by a qualified electrician to ensure that it is done safely and in compliance with the National Electrical Code. It is important to note that simply using a 2-prong adapter to plug the non-grounding plug into the grounding receptacle is not an acceptable solution. These adapters typically have a grounding tap that is supposed to be connected to the screw on the receptacle cover plate. However, in many cases, the receptacle cover plate is not properly grounded, or the grounding tab is not properly connected. This means that the adapter does not provide a reliable grounding path, and the safety hazard remains. In addition to the National Electrical Code requirements, there may be other local codes or regulations that apply to this situation. It is important to check with the local building department to ensure that all applicable codes are being followed. Ignoring code violations can have serious consequences, including fines, legal liability, and, most importantly, the risk of electrical shock or fire. Electrical safety is paramount, and it is essential to ensure that all electrical systems are installed and maintained in accordance with the National Electrical Code and other applicable codes and regulations. When dealing with electrical work, it's always best to consult with a qualified electrician. They have the knowledge, skills, and experience to ensure that the work is done safely and correctly. Attempting to do electrical work yourself without the proper training can be dangerous and can lead to serious injury or death. The National Electrical Code is updated every 3 years to reflect changes in technology and best practices. It is important to stay up to date on the latest code requirements to ensure that your electrical systems are safe and compliant. The National Fire Protection Association, or NFPA, is the organization that publishes the National Electrical Code. The NFPA website is a valuable resource for information on electrical safety and code compliance. In summary, plugging a non-grounding plug into a grounding receptacle is a code violation and a safety hazard. The National Electrical Code requires that all receptacles on general-purpose branch circuits be grounded and that grounding type attachment plugs be used. To comply with the National Electrical Code, the owner should either replace the non-grounding plugs on the light fixtures with grounding type plugs or modify the light fixtures to connect directly to the branch circuit wiring using a junction box or hardwiring. Always consult with a qualified electrician when dealing with electrical work to ensure that it is done safely and in compliance with the National Electrical Code. Let's discuss some of the potential hazards associated with using non-grounding plugs and grounding receptacles in more detail. One of the most significant hazards is the risk of electric shock. As mentioned earlier, in a properly grounded electrical system, a fault current will flow through the grounding conductor back to the electrical panel, causing the circuit breaker to trip and shut off the power. However, if a non-grounding plug is used, there is no grounding conductor to provide a low impedance path for the fault current. In this case, the fault current may flow through other paths, such as through a person who comes into contact with the energized metal enclosure. The severity of the electric shock depends on several factors, including the voltage of the electricity, the amount of current flowing through the body, and the duration of the exposure. Even a relatively low voltage can be dangerous if the current is high enough. Electric shock can cause a range of injuries, from mild tingling to severe burns, muscle contractions, and cardiac arrest. In some cases, electric shock can be fatal. Another hazard associated with using non-grounding plugs and grounding receptacles is the risk of fire. If a fault occurs and there is no grounding path, the fault current may flow through other conductive materials, such as the building's wiring or metal pipes. This can cause these materials to overheat and potentially ignite nearby combustible materials. Electrical fires can spread quickly and be difficult to extinguish. They can cause significant damage to property and can also pose a threat to human life. In addition to the immediate hazards of electric shock and fire, using non-grounding plugs and grounding receptacles can also damage electrical equipment. If a fault occurs and there is no grounding path, the fault current may flow through sensitive electronic components, such as computers or televisions. This can damage these components and render them unusable. Even if the equipment is not immediately damaged, the prolonged exposure to fault current can shorten its lifespan. It's also important to consider the potential liability associated with using non-grounding plugs and grounding receptacles. If someone is injured or property is damaged as a result of an electrical fault, the owner of the property could be held liable. This liability could include medical expenses, lost wages, property damage, and legal fees. In some cases, the owner could even face criminal charges. For all of these reasons, it is essential to ensure that all electrical systems are properly grounded and that only grounding-type plugs are used in grounding receptacles. This is not just a matter of code compliance, it is a matter of safety and responsibility. Let's talk about some specific examples of how these hazards can manifest in a retail environment. Imagine a customer is leaning against a metal display case that has a light fixture plugged into a grounding receptacle with a non-grounding plug. If a fault occurs in the light fixture, the metal enclosure of the display case could become energized. If the customer touches the display case, they could receive a serious electric shock. Or consider a situation where a faulty wire in a light fixture comes into contact with a metal conduit. If there is no grounding path, the conduit could overheat and ignite nearby cardboard boxes, causing a fire to break out in the store. These are just two examples of the many potential hazards that can arise from using non-grounding plugs in grounding receptacles. It's important to be aware of these hazards and to take steps to prevent them. Now let's delve into the practical steps involved in correcting this code violation. If the decision is made to replace the non-grounding plugs with grounding plugs, it is crucial to select the correct type of plug. The plug must be rated for the voltage and amperage of the circuit, and it must be compatible with the receptacle. It's also important to choose a plug that is suitable for the environment in which it will be used. For example, if the light fixture is located in a damp area, a waterproof plug should be used. The installation of the new plug should be performed by a qualified electrician. The electrician will need to disconnect the old plug and carefully connect the wires to the new plug, ensuring that the grounding conductor is properly connected to the grounding pin. The electrician should also test the connection to ensure that it is secure and that the grounding system is functioning properly. If the decision is made to hardwire the light fixtures, the process is a bit more involved. The electrician will need to disconnect the plug and receptacle and run the wiring from the light fixture directly to a junction box. The junction box should be properly grounded and should be located in an accessible location. The electrician will then connect the wires from the light fixture to the circuit wiring using wire connectors. Again, it is crucial to ensure that the grounding conductor is properly connected. After the wiring is complete, the electrician should test the circuit to ensure that it is functioning properly and that the grounding system is working as intended. In either case, it is important to document the changes that have been made to the electrical system. This documentation should include the date of the change, a description of the work that was performed, and the name of the electrician who performed the work. This documentation should be kept on file and made available to the inspector upon request. Finally, it is worth emphasizing the importance of ongoing maintenance and inspection of electrical systems. Electrical systems should be inspected regularly for signs of damage or wear. Any problems that are identified should be corrected promptly. This will help to ensure that the electrical system remains safe and compliant with the National Electrical Code.